This lecture is on recursion, so we can solve problems, any algorithm can be implemented using recursion or using iteration. So iteration means I can do this using loops, okay? And this is non-loops. I can't use loops in here. So that is the major difference here. Now, there is a series here known as the Fibonacci series. The way this series is done, the Fibonacci, you start 0, 1, you add the previous two. So 1 is 1 plus 1, 2 is 1 plus 1, 3 is 2 plus 1, 5 is 3 plus 2, 8 is 5 plus 3, 13. So this goes on and on and on, depends on the limit. So, this is the first Fibonacci series, Fibonacci second, so I did assign it here. Now if I have to do this recursively, the Fibonacci of a number, n, in this case it's 4. For the fourth term, this is 0, 1, 2, 3, 4. See, 4 is, the fourth term is 3. So this is the Fibonacci of the fourth term. Is the Fibonacci of the third term, which is 2, plus the Fibonacci of the second term, which is 1. So if you add 1 plus 2, that gives me 3. And that's how the Fibonacci. So I'm going to build what is known as the Fibonacci 3. The Fibonacci 3 says the Fibonacci of the fourth term, which is 3, is generated by taking the Fibonacci of the third term plus the Fibonacci of the second term. The third term is 2, the second term is 1. Then we can still break this down. Fibonacci of the third term is the Fibonacci of the second term which is 1, and the Fibonacci of the first term, which is still 1. So see, Fibonacci of 1 cannot be, I can't break that down any further. So Fibonacci of 2 is the Fibonacci of the first term and the 0 term. So this is the second term, not the Fibonacci of 2. This Fibonacci of the second term. Fibonacci of the second term is the Fibonacci of the first term plus the 0 term. Now, if you backtrack here, so the Fibonacci of the second term, which is this, okay, is the first term, which is 1, and I wrote that there, and the Fibonacci of the 0 term, which is 0. Now, so what I'm going to do, I go down to the lowest level. So the Fibonacci of the fourth term. So the Fibonacci of the fourth term. Okay, and that happens to be 3. So the Fibonacci of the fourth term is 3. Is the Fibonacci, so I have Fibonacci of this, of the first term, which is 1, plus Fibonacci of the 0 term, which is 0. Fibonacci of the first term, which is 1, plus the Fibonacci of the first term, which is 1, plus Fibonacci of the 0 term, which is 0. So if I add 1 plus 1 plus 1, so that gives me 3. So that means the Fibonacci of the fourth term is 3. This is the code that I wrote recursively. So what you do is you pass the term. So like if I pass the fourth term here, would be 4 less than equal to 0. Then I go else if 4 is equal to 1, then I'm going to call this recursively. Pass Fibonacci of 4 minus 1, so, and then plus Fibonacci of 4 minus 2. So it's going to repeat the process again, just like we're doing here. So eventually I'm going to end up with, these terms. So we take at the bottom. So again, to reiterate, anything that I can, any algorithm that I can write recursively, meaning don't use loops, I can also implement, I can implement it using iteration, which is actually using loops. And the Fibonacci series is a series that can go on and on. And if you look back here, just to revisit this part, so I'm saying Fibonacci of 4 is the Fibonacci of 4 minus 1, which is 3. The Fibonacci of the fourth term is the Fibonacci of the fourth term minus 1, which is the third term, plus the Fibonacci of the fourth term minus 2, which is the Fibonacci of 2. And this can be broken down. So, and here's the list. So if you look at the Fibonacci of the 0th term is 0, Fibonacci of the first term is 1, Fibonacci of the second term is 2, the third term is 3, our fourth term is 3, and fifth term is 8, and I can say the sixth term can be 13, so again, and again. So this should go on and on up to the limit. So thank you for watching this video, and thank you.